All right, there it goes. So today, we are now putting into action all of those exponent notation rules we learned yesterday. So we're starting off where we learned that if the base is the same, the big number, then we can add the exponents and combine them for an easier problem. So if you notice in your rule box, it says x to the m power times x to the n power would give you x to the m plus n. That's just the basic algebraic rule. So let's look at some example problems. Look at exercise 1. 14 to the 23rd times 14 to the 8th. Are the bases the same? Yes, they are. So I rewrite that. And then I add the exponents. And what do you get? 31. And there's your answer. Now, if you had to put it in the calculator, you could. We are not focused right now on getting the whole number answer. We're focused on being able to write it in exponents, okay? Let's go to number 2, or exercise 2 is below. So for exercise 2, I see that my base is what? Negative 72. I make sure I put what? Parentheses, and then I look at my two exponents and I get 23. For exercise 3, my base is 5, and my exponent, what is it? 172. And then for exercise 4, I make sure I have my parentheses to the exponent of 14. Okay, so now let's look at a little more on algebra examples. So if you go to exercise 5, it says a to the 23rd times a to the 8th. What is the base? A. Is it the same for both? Yes. So therefore my total is 31. What is the base in exercise 6? F. And the exponent? Okay. Any questions so far? For exercise 7, my base, B, and my total? And now they want you to just kind of fill in the blank. If you have negative 3 to the 9th power, and I want to get to negative 3 to the 14th power, what would this exponent have to be? 5. Turn the page. Okay, so now that we know what it looks like to add exponents, let's see some other situations. Look at exercise 9 and 10. I want you to take about 30 seconds to think about it. It asks us what would happen if there are more terms with the same base. Just take a couple of seconds to think about it. All right, John Trowell, what do you think? Is there anything different? Does it matter that you have a longer list of bases and exponents? Does the rules still apply in those situations? Yes. So you just check the bases. Yep, they're the same. And what is your total of exponents? What about for this one? So it doesn't matter if they have a long expanded form of bases. As long as the basis is the same, you're good to go. So that leads us to, what if the bases are not the same? Look at exercise 11. Can you combine the exponents for 6 and 4's problem? Can you? No, the rule says they have to be the same to combine the exponents. So all you can do is combine what can be combined and make it a multiplication fact simplified. So what does that look like? I find all of the 6's, and that becomes 6 to the 19th times 4 to the 12th, because I cannot combine these two. They have different bases. Now, Could I multiply this out, and multiply it together to get a whole number? Yes, but I cannot do anything with the exponents if the bases are not the same. Look at this one. Scratch out this. Hold on 1 second, I'll get to you after this. No, scratching out this piece. Can you somehow rewrite the 8 to make it have a base of 2?
Nope.
Could you?
Maybe.
What would it be? What would 8 be written in base of 2? 2 to the 3rd power. And then if I have 2 8s, that's the same as this, isn't it? Times this 2 to the 4th. So how many 2s would I have?
3. Oh, wait.
10. So I can also group the bases if I can take a common factor of them and rewrite it, okay? You're not going to use this much, so don't panic, but it is good to know that you can recognize that 8 could be broken down to 2 to the 3rd, okay? Question. Jamari. For now, yes, leave them in, because I want you to concentrate on writing them in exponents right now. All right, so look at exercise 12. I've got a base of -4 and a base of 17. Do they have something in common that we could break down? No. So all we can do is combine all the -4s and combine all the 17s, and we're done. So go ahead and write your answer. Making sure you got those parentheses where they need to be. Now look up when you're done and see if it matches mine. That's all you can do. You cannot combine these. They have different bases. All right, look at 15. Scratch this out. Now, can you rewrite 9 in the base of 3? What would it be? 3 to the 2nd power. Now can you combine it? What does it become? 3 to the 9th power. See? So sometimes you can reorganize it to write it in exponents, but I'm going to be honest, if you're doing a really long, hard problem later on this year, why go through all that? Just do the math really quick. You see what I'm saying? But you need to be aware of it in case it does show up. Okay? So let's go to this one, exercise 13. Are the bases the same? 15 and 7? No. So I can combine the 15s. How many? 3. Because I've got 2 here and I've got 1 here. So how many 15s do I have? 3. I cannot tell you how many times people miss that on a quiz. And it will be on your quiz Monday. If it does not have an exponent, it's a 1. So then you still have to add it. The rule is add it. So 2 plus 1 is 3. So then 7 would be to the 6th power. What about the last one? 5 to the 4th times 2 to the 11th. Are the bases the same? No. Can you change the 5 to a base of 2? Nope. So what can you do? Leave it exactly like that. So now let's step in a little bit more of algebra. Look at exercise 17. Exercise 17 gives us a problem that has both variables and numbers in it being multiplied. And the rule for the exponents is the base has to be the same. Okay, so what is the exponents attached to? The x's. So are the bases the same? So I can combine those x's. But can I also combine 2 and 17? Are they both numbers?
Well, yeah.
And what operation are we doing? Multiplication. So let's handle the numbers first. What would that become?
34.
34. Now the exponents,
X to the 10th power.
and that is your answer. So you're going to have to break them down after you learn the rules. How about distributive property? If you get something that looks like this, what do you do with distributive property? Not combined like terms. Be careful. You what? I can't, hold on, I can't hear Kenny. You do? Okay, so you do whatever's in the parentheses first, but when it's distributive property, you take the outside term and you multiply it by everything on the inside. So the first terms I'm going to multiply are A times A. What do we get? A squared, because this is 1 and 1, and 1 plus 1 is 2. So I get A squared. Then it's a positive, positive. A times B is AB, and you're done. Okay? What about if we did it in reverse and we had this? Okay, hold on. Let's stop right there. B times A gives me BA. But in algebra, it's always appropriate to put your letters in alphabetical order. So this should be AB plus B squared, because you've got a B here and a B here. If it helps you to put a 1 by each letter to remind yourself that it's 1, you can do that. Skip this one. We're doing that later in the year. So let's talk about the second rule, because multiplication's pretty easy, right? Do you agree with the statement that division is the inverse of multiplication? What does that mean?
You can multiply and divide the same number.
It undoes each other, right? If I multiply two numbers together, then I could divide one of those numbers by what I multiplied together. It undoes subtraction. Multiplication. So if we add when we multiply, what do you think we do when we divide? Subtract. So the rule for dividing exponents is that you subtract the exponents when the bases are the same. Okay? So the bases still have to be the same. So let's look at this. This blew some people's minds in last class that a fraction is a division problem. Some people don't know that, and it's important that you do. Because I'm going to teach you a trick that's going to help you later on in algebra. When you are dividing exponents like this, you need to put the answer on the top or the bottom based on which exponent is larger. So let me demonstrate. Here's the answer, the question they just gave us, right? So I'm going to say, okay, the bases are the same. 9 minus 6 is 3. So my answer is going to go on the top. What goes on the bottom? Nothing. A 1. It's a whole number. So this answer is 7 to the third. Okay? Let's say, though, you were given a problem that was 7 over 6 over 7 over 7 over 9. Like this. So what you're going to do, we're talking negatives now, which we haven't got into yet. So what I want to show you is the trick. Still subtract them. 9 minus 6 is 3. But which one of these is bigger? 9. So you're going to put your answer on the bottom in that case. Because, just to kind of clue you in, this becomes 7 to the negative 3. So there's the negative. Do you see it? But what I'm doing is I'm teaching you a shortcut to keep it from being negative. And we'll discuss that in the coming days. So let's look at exercise 23. Are the bases the same? So then my answer is 8 over 5, keep in my parentheses, to the 7th power. Remember, we're subtracting when we're dividing. Okay. Do 22 and 24, and we're going to check your answers. I'm looking for those parentheses. So exercise 22 was -5 to the 9th power. And exercise 24 was 13 to the 1 power, which is the same as 13. Okay, turn the page. So let's talk a little algebra. A over B, is the base the same? Yes, so just leave it as algebra. And 9 minus 2 is 7. What about if you just have x? What would it become? X to the 1, which is the same as x. You could see it either way. So now they kind of give you the same setup as before. Scratch this out. Are the bases the same? No. Can you change 4 to a 2 base? Yes. 4 is 2 times squared, right? So I've got to do that twice to get this answer. Times the 2 to the 7th. So how many 2's do I have? 11. 7, 8, 9, 10, 11. Now, if it's written like this, these bases are the same, and these bases are the same. Do you agree? So I can combine this times this. I cannot put them together. Why? The bases are different. Stop me. Anybody confused? Yes. Which one? For exercise 29? So the 3's were the same. So 5 minus 2 is 3. The base was 3. Then the 2's were the same. So 8 minus 3 is 5 with the base of 2. But I can't combine these because 3 and 2 have different bases. So look at 28. Scratch this out. Notice, can the 27 be written in the base of 3? What could it be? 3 to the 3rd. And then you can go ahead and combine with 3 to the 23rd. So it's going to be 3 to the 23rd over 3 to the 3rd, which becomes 3 to the 20th power. Guys, I got to go back up here. I messed up, and this is probably where I confused you. Because I went in and multiplied it. That's not right what we're doing. So you've got this correct. You're just going to have 2 to the 7th over 2 to the 4th, and you're subtracting. That's where we made this mistake. I'm sorry. I wanted to correct that on the video. And then look at the last one. These are the same, and these are the same. And I have kids that box them in like that to help each other. So what does this become? Second power times 95 to the first power. Do I have to write the 1? No, I do not. Last problem. Look at exercise 31. So you have a fraction and a non-fraction. How do I make this non-fraction a fraction? Put a 1 over it. So I could technically rewrite the problem to look like this. Do you agree? Yes. Then I could rewrite the problem by combining the top to be this and combining the bottom to be this. Do you agree? Look at it before you say yes or no. All I did was multiply across the top and multiply across the bottom. See how I did it? Now, can I do any combining with that? I can combine the x's because the bases are the same. So where does the 15 stay? On top. And then the x's are going to be,
15 x.
see? Yep. Let's look at b really quick and then we're going to wrap today up. 5 over x to the third times, look what I'm doing. I am writing it as a fraction so it makes sense. So now I'm going to multiply across the top. What do I get? 5 times negative 4, negative 20, x to the 6th, over x to the 3rd. Now what can I combine? The x's. See, y'all picking out those bases. So the negative 20 just hangs on top, and it becomes x to the 3rd, and I've simplified. Yes?
I'll test on this tomorrow.
Do what?
I'll test tomorrow on this one.
No, this is Monday. Tomorrow we're learning another rule. So tomorrow when you come in,